Hello Year 11 and welcome to another week of remote learning, where this week we will be looking at 3D trigonometry and 3D Pythagoras. Now in theory there's nothing really new that we're going to talk about here. However, it is often quite difficult to conceptualise exactly what you need to do in some questions. So I'm going to use the next 10 minutes or so to go through 4 examples of the sorts of questions you can expect in order of increasing difficulty, I hope. And so we have our first question in front of us, a cuboid A, B, C, D, E, F, G, H, and you're given some information. And my first piece of advice always is that if the information is not labelled on your diagram, just label it for yourself. So we have 4 centimetres, that's AE, AD is 5 centimetres, that's here, and DC is 8 centimetres, and that's here. That just helps me significantly picture exactly what I'm doing. Calculate the length AG, and again, it will help me to just draw roughly what AG looks like on my diagram, connecting A to G. Give your answer to 3SF, and in an exam there'd be an answer box, so I would just write 3SF down below my answer box so that I remember to round at the end. So I'm looking for this length here, and effectively what I'm asking myself therefore is, where is a right angled triangle that I can use? And the right angled triangle with AG is going to have AG as its hypotenuse. So my right angled triangle that I can use is AGC. AGC, this triangle here. Now you may be able to visualise all this and not need to draw all of it out, but I can't just yet. And then we label anything that we know. So AG, that's what we want to know, that's our quantity. I also know GC, because this is a cuboid, GC will be 4 centimetres. But I don't know AC yet, so I need to find a way to work out AC. And if I look on my diagram, I have another right angled triangle, AC, CD, DA. I have this right angled triangle here. AC is now my hypotenuse. Here are my right angles. And then I have CD is 8 centimetres and AD is 5 centimetres. So I can find AC then using Pythagoras. The square root of 5 squared plus 8 squared is root 89. And I'm just going to leave that in third form. I'm not going to round if I can avoid it. So AC was root 89. That goes onto our diagram here as well. Centimetres, remembering my units. And now I can find AG. Pythagoras' theorem, square of the hypotenuse is equal to the sum of the squares of each side, root 89 squared plus 4 squared. Typing into my calculator and square rooting both sides, I have root answer squared plus 4 squared, giving me, for AG, root 105. And then they want their answer to 3SF. So that's 10.246 and so on, which to 3SF is 10.2 centimetres. We move on to look at another question here, which uses exactly the same cuboid, which is helpful because it means that I'm already familiar with some things here. I know 4 centimetres, I know 5 centimetres, I know 8 centimetres and my dimensions. We're already given those in the exam. And I'm asked to find the size of angle ECA. And again, I'm going to just draw that to help me on my diagram. E to C to A. Once again, you may be able to do this in your head, but I certainly cannot. And it's this angle here that I want. Now, one thing that's jumping out at me straight away is that once again, with our right angle triangle, we have AC. And we calculated that in the previous question. So we have EAC. We want that angle there. Let's call that angle theta. Let's call that angle theta. So let's start labelling things. We know EA is 4 centimetres, and we've already worked out AC in our previous question. AC was root 89 centimetres. So we've got a right angle triangle. We know the opposite and the adjacent. So that gives me tan theta is equal to my opposite, 4 over my adjacent, root 89. No, I've not rounded once again. So I take inverse tan of both sides. theta is equal to arctan, or tan, minus 1. Remember, not the power of minus 1, just inverse tan of 4 over root 89. Again, it's asked 3SF, so I would really have noted that down at the beginning. And then I'm typing into my calculator tan minus 1, 4 divided by root 89. And that gives me my answer. Theta is 22.9769 and so on, or to 3SF 23.0 degrees. The third question looks at a new context here. We have a triangular prism instead. CD is 20 centimetres, AD is 30 centimetres, ADC is 35 degrees. I've labelled that slightly strangely though in the question. Calculate the size of angle the line AF makes with the plane ABCD. AF. The plane ABCD is this thing here. So once again, my right angle triangle is going to be this triangle here. And indeed, in this exam question, they have labelled that angle incorrectly. ADC is 35 degrees. I wonder if they mean FDC. Nevertheless, we want the size of the angle the line AF makes a plane ABCD. So we want this angle here, giving it answer to 3 significant figures. And so we have that triangle, which I'm going to redraw now, of AFC. We've got a right angle. We want to work out this angle here. Let's call it theta. So we need to know any 2 of these sides. So we can use right-angled trigonometry. At the moment, we don't know any of them, but we can work out AC fairly easily because I have this right-angled triangle here, ADC. So another right-angled triangle, ADC, where AD is 30 centimetres, DC is 20 centimetres. So using Pythagoras, AC is equal to the square root of 30 squared plus 20 squared, which is 10 root 13 centimetres, 10 root 13 centimetres. And then we want to look at FC. And that reveals the issue in this exam question. That should say FDC. And then indeed this angle here is 35 degrees, because that allows us to work out the length of FC, because I've got the base of my triangle and I've got an angle and I want to find out my height of the triangle. So I've got opposite, I have an adjacent, so that gives me, in my third triangle here, let's redraw that, FDC. I know that's 35 degrees, I know that's 20 centimetres, this is the length I want. I want my opposite, I've got my adjacent. Tan 35 is equal to this length here, FC, divided by 20, or FC is equal to 20 tan 35. 20 tan 35, giving me 14.0 centimetres to 3 SF. So I know this is 14.0 centimetres. And then I want to work out this angle here. Once again, I've got the opposite, I've got the adjacent. So tan theta is equal to my opposite, 14.0, although I'm going to use my unrounded value on my calculator, over my adjacent 10 root 13. Once again, taking inverse tan of both sides, theta is equal to inverse tan of 14.0 over 10 root 13. So typing that into my calculator, shift tan gives me inverse tan, fraction, answer, because that was what my 14.0, my 20 tan 35 was, over 10 root 13. That's exact because I've left it in surd form, giving me my answer, and it says 3SF again, of 21.2 degrees. The final question I want to look at is a little bit more involved, but you're all more than capable of doing it. The diagram shows a pyramid. The base of the pyramid, ABCD, is a square. AB is 15 centimetres. Once again, I'm going to label that because it helps me. And because it's a square, That also means AD is 15 centimetres. And angle PAC, like that angle there is 65 degrees. Calculate the volume of the pyramid. So as soon as I'm being asked volume of a pyramid, I need to recall my formula for the volume of a pyramid. The volume being 1/3 times the area of my base times my vertical height. So 1/3 is fine. The area of the base is also fine because you know it's a square of side length 15 centimetres. So that gives you 225 centimetres as your area of your base. So it's just h we want to work out, and h is the vertical height, remember. So the height from the point of the pyramid to the centre of its base, which we'll call O. So now we're a bit practiced. So I'm looking at this. Well, I know 65 degrees. They've given me that. So I'm probably going to be using this triangle here, 65 degrees. Then I've got A, O, and P. And because it's vertical height and my base is horizontal, that gives me a right angle. So in order to work out PO, which is my vertical height, I just need to know either AP or AO. Well, that's a little bit trickier here than it has been before. My easiest approach here is to look at AO, because what I can do is I can drop a line here and form another right angle triangle, and I know these lengths. Let's call that M, because O, remember, is in the middle of my base. So when I drop that down here, I'm going to get in the middle of AD. So I have this triangle here, AOM. And AM, I said, is the middle of AD. So if AD is 15 centimetres, this is 7.5 centimetres. And equally, if we look at OM, that's going to be half of this distance here. And the side of your square is 15 centimetres, so OM is also going to be 7.5 centimetres. So to work out AO, I use Pythagoras, the square root of 7.5 squared plus 7.5 squared, giving me 15 root 2 over 2, which is to be expected centimetres. Again, working in third form, so that I am not making any rounding errors. And then I want to find h. So I now know my adjacent to 65 degrees, and I want my opposite. So again, tan 65 is equal to opposite h divided by 15 root 2 over 2. So h is equal to 15 root 2 over 2 times tan 65, which is 15 root 2 over 2, answer, times tan 65, gives me 22.7459, and so on for my value in centimetres. So I go back to my volume, because it asked for the volume, is 1/3 times the area of the base times this height, which is 1/3 times the area of my base times answer, which gives me 1706 centimetres cubed to the nearest cubic centimetre. I should have been saying cubic centimetre all the way through this, actually, so I apologise for that. That's about as hard as this can get. You've used Pythagoras, you've used multiple triangles, you've used right-angled trigonometry as well. So with that, you're ready to go and tackle the harder Dr. Frost maths question.